Okay, this is section 3.2, adding, subtracting, and multiplying polynomials. Our goal is to combine like terms. Example 1, adding and subtracting polynomials. To combine like terms for this, the variable and the exponent have to match. You are not combining everything into a single term. You cannot combine letters and numbers. For example, these two cannot combine. And now we also have to remember the letter and the exponent must match. So let me show you how I do this. You don't have to use different colors. This is just how I view this. We are adding these together, so we do not need to flip any symbols. I underlined my like terms in these different colors. I'm not going to be doing this in the future. This is just for your introductory lesson. 6x to the third and 2x to the third gives me 8x to the third. Then I go to see my squared term. So we're doing this in standard form. Do not just put these in a random order. 1x squared and negative 8x squared give me negative 7x squared. Oops. 4x is the only one of its kind, and then we have negative 7 and positive 3. Well, when we combine those, we get negative 4. So all we are doing is combining like terms. Letter B. This is subtraction. What you have to do, get this back up here. What you must do before what we did for letter A when we just combine them is distribute the negative to every term next to the negative sign. We do not distribute a positive sign because that doesn't change anything. So now we have negative 2x squared y squared, negative 3x y squared, and plus 2x. Don't let the double variables psych you out. We're still following the same rules of combining only those with like terms. So I combine my x squared y squared with my x squared y squared, giving me 1x squared y squared. My xy squared, notice that that's just a single x. I combine those to get a single xy squared. Remember, you're not going to see something like 1x or 1xy squared. It's just going to be the variables itself. Oops, that's supposed to be erasing. There we go. And then 6x squared, 2x squared gets me 8x squared. When you have a lot of variables like this, the order doesn't matter as much. Usually I just pick a variable and go with it, but order doesn't matter too much. Just make sure you're combining correctly and getting the terms correct. Okay, now it's your turn. Try it. Go ahead and pause the video, and then we'll come back and do this together. Okay. So I start by looking for my highest degree. I see fourth power is my highest degree. No other fourth power to combine with, so that goes first. And when I finish combining something, I cross it off. That way I don't count it again by accident. Next up is my third power. I have a positive 5a and a negative, a to the third, and negative 6a to the third. That's negative 5. That's negative 6 and 5. So negative 1a to the third. That's 5 minus 6. Cross them off because we're done with them. Next up, we have our a squareds right here. That's a positive 7 and a negative 3. That gets me positive 4. A squared. Cross them off because we're done with them. A single a over here with 2a gets me 3a, and then positive 1 and negative 2 gets me negative 1. So all this is just an amped up version of combine like terms. Letter B. Distribute the negative. Flip your symbols. And then combine your like terms. So again, for this one, the order doesn't really matter too much. I'll start with the a squared b squared. I see I've got 2 and negative 3, so that's negative 1 a squared b squared. Okay, so we're done with those. Let's see. We'll do this one. a squared b, 9 minus 5, positive 4, a squared b. Done with those. And then negative 7 and positive 3, so that's negative 4, ab squared. So notice, once you match up the letters, you don't ever change these. You're just focusing on the numbers in front. That's how I'm able to get my answers so quickly. I'm just focusing on the coefficients now that I've matched up the variables. That's adding and subtracting. Moving on. Multiplying polynomials. This is just distribution. A couple of tips. When you multiply the same variable, for example, this one here, 2m times 3m squared, that becomes 6m to the third power. You have to remember your rules from Algebra 1 when you're multiplying exponents. Add the exponents when you multiply the same variable. Now for this one here, notice how I lay this out. In the red, I have my terms that result from being multiplied by 2m, right here. So this first term is 2m times 3m squared. This second term is 2m times negative 4m, and this third term is 2m times 2. You may be used to the word FOIL. That doesn't apply here because FOIL only works when you have 2 terms times 2 terms. We've got 2 times 3. But the idea stays the same. Next up, I'm multiplying my 5 times the 3m squared. Notice I went to a different line because I'm trying to line these up where I have the like terms on top of each other. It makes it easier to add them together. You can just continue writing them across in a straight line, but it's not always as pretty. All right. Next up, you want to add your like terms. Just add them down and write them in standard form. So again, multiplying polynomials is just distribution. You have to remember, though, when you multiply 2 of the same letter, like m and m squared, the exponents combine. To give you a small example, if we had x times x to the 4th, well, guess what? That's x to the 5th because that's a first. These basic rules are things you need to remember. This next part is for my honors only students, so if you are not in Algebra 2 honors, feel free to go to the next part. Okay. Pro tip for when we're multiplying 3 things, save this one for last and just start with your first ones, your 2 by 2, 2 times 2. Okay? 7x to the 4th times negative 3x squared is negative 21x to the 6th. Again, I can't state this enough. You add the exponents when multiplying the same term. So again, the red is from multiplying the 7x squared to both of these terms. The blue is from multiplying the regular x. With these ones here, there were no like terms to combine, so I just brought everything down. And now is when we bring down our one we save for last. So I put this back in parentheses. You'll notice I didn't underline all of these little ones. I'm much more a fan of taking the 2 terms and multiplying it into all of these terms, as opposed to taking 4 terms and having 4 separate lines. So the red is the result of multiplying all of these by 1. The blue is the result of multiplying all of these by negative 2x to the 3rd power. Okay? Ooh, that should be positive. So positive 42, x to the 9th, x to the 6th and 3rd combined. Negative 28, x to the 7th, positive 6x to the 5th, and negative 2x to the 4th. I saved this very step for last. Now we combine our like terms and put in standard form. So the highest power goes first, 42x to the 9th. And when I finish something, I cross it off. X to the 7th is our next highest term, followed by x to the 6th. X to the 5th. We have some x to the fourths to combine. That's 14 and -4, so 10 x to the fourth. Oops. Okay. No x to the thirds, minus 3x squared plus 2x. That extremely long polynomial is our answer. Okay. So this is the try it section for regular, just this one simple problem. And it looks like I accidentally put the answer there, so let me erase that real quick. You saw nothing. And then for my honors students, that second one's if you're only for honors. Let's go ahead and pause this and give it a shot. All right, the answer reappears. 6n squared multiplied into these three results in the first line of terms. -7 multiplied in results in the second. And I combine like terms if there are any. I'm able to combine my regular n's, but that's about it. These don't combine just because they're below each other. They have to be the same letter and exponent. Okay? Honors. I want to follow my own rules from my problem and save that third one for last. Multiplying 5y to the third power into here results in these two terms. Same thing for 1, so all this stays the same. No like terms to combine just yet. Multiplying -8 to all four of these terms results in the first line, and multiplying 2y into these four terms results in the second line. So now I'm going to combine my like terms. Actually, it looks like I already did, so let me double check my work. Always double check your work. Mistakes are always possible, especially if you're going too quickly. All right. Highest power is y to the 6th. That goes first. Y to the 5th. Looks like we have 2 to combine. 10 and 80 gets me 90. Y to the 5th. Just a little tip. When you're adding these together, you don't increase the exponent. Please don't make that mistake. Y to the 4th, that's as only of its kind. Y to the 3rd, same thing. Y squared, it looks like I have 16y squared and 2y squared, and then -8y. That is the end of the lesson for today. Your homework is attached right here. 3 problems of adding and subtracting, 3 problems of multiplying. This last problem is honors only. Though if you were in my regular class, you are more than welcome to give it a shot. And that's all for today.